calcium carbonate, CaCO3. It's one of those molecules that kind of appears like everywhere and most people don't know anything about. So you're not a chemist, I'm not a chemist, but we do need to know a little bit about how this molecule is built. So basically what we have is this ionic bond, calcium over here and carbonate over here. So carbonate is a carbon atom with 3 oxygens, giving it a 2 negative charge. Calcium has a 2 positive charge. And the 2 molecules attract each other with an ionic bond, and there we go, calcium carbonate. It's found like everywhere in nature. The mineral form of calcium carbonate is second only to silicon dioxide or quartz. It's found in limestone, it's found in caves as stalactites and stalagmites. Most seashells, calcium carbonate. It's the main component of marble, coral reef, eggshell, that hard part, yeah, that's calcium carbonate. It's got 3 different mineral forms found in nature: calcite, aragonite, and vaterite. The most stable form of all of its minerals is calcite. Vaterite's not very stable, so it's not found in huge quantities in nature. Limestone is a mixture of calcite and aragonite. You squish it down and heat it up, it goes through the metamorphic process and it becomes marble. And all the impurities in it, whether it's like sand or iron feldspars, or they form all those fun little colors and marbling texture. If you take a calcium mineral supplement, you're literally eating calcium carbonate. It acts as a great antacid in the body, though too much is bad for your health. Calcium oxide is extremely important in manufacturing. It plays an important role in iron smelting, where it's used to separate impurities from the ore. In order to get calcium oxide, we use limestone, we use calcium carbonate, and we heat it up in a kiln. It's called calcification. When you heat up calcium carbonate, a CO2 molecule is able to break out of the carbonate group, and what you're left with is calcium oxide, CaO, also known as quicklime. The most common types of glass that we see in things like windows and cookware and jars is about 10% calcium oxide. Used on its own, it's called lime mortar. We don't use lime mortars anymore because they kind of dissolve over time, but when you mix it with a couple of other things, you create what's called Portland cement. It's the main cement that we use, and you mix it with an aggregate such as gravel and sand, and you get concrete. So calcium carbonate is an essential precursor for both concrete that's used in buildings and roads, and glass that we use for our windows and our glasses and everything that we do. So calcium carbonate is hugely important in all these things that make up our modern life, but the problem is most of it releases carbon dioxide because it's calcium oxide that we want, and calcium carbonate is simply our precursor. Calcium carbonate is one of Mother Nature's big way of storing carbon, called carbon sequestration. Calcium carbonate is found in such high quantities in the ocean. Creatures in the ocean are going to be taking carbon dioxide in the air, mixing it with calcium and oxygen, making this calcium carbonate molecule, which is then going to precipitate out and land on the bottom of the ocean or form coral reefs and things like that. It's a way of storing the carbon dioxide to remove it from the rest of the environment. That's where all the limestone and the marble came from to begin with, is oceans millions and millions of years ago. We take limestone, we take marble, and we grind them up and we heat them up, and we release all this CO2 that Mother Nature had stored away, and we're changing the planet's climate. But calcium carbonate in its crystalline form as calcite is one of the most important minerals in the history of modern physics. Don't believe me? Join me next week on Tech Laboratories when we explore the importance of calcite to the history of optics and the study of light. For Tech Laboratories, I'm Tech Adam, saying keep thinking, and thanks for watching. Hey guys, Tech here. Don't forget to like this video, share it with your friends, and subscribe to Tech Laboratories by clicking on the links below for more weekly science and technology videos. Till next time. This clear piece of crystal right there, that is a piece of calcium carbonate. So we're going to heat it up using the torch in my makeshift crucible here. You can now see how the crystal is white instead of transparent.